Good afternoon. Hope you had a good lunch. My name is David Atkinson. I'm a product manager at Redgate. I cover SQL Compare, SQL Source Control, and the continuous integration story. So I'm going to talk about what is database continuous integration, why you might want to do database continuous integration, and most importantly, how to get up and running, because it's quite a new concept. It's something that has been around for a while for traditional application development, but not so much for database development. So I'll be running some demos. It's not quite as bad as you might think. And we'll be looking at SQL Source Control, because that's a tool that you need in order to, you need to put your database in Source Control in order for that to trigger the continuous integration process. You'll need a continuous integration server. In my case, I'll be using TeamCity, and that's because that's something that we use at Redgate. But you might already have one in your organization, and that's the one that you should use if you try to get this up and running, because there's no point in having multiple tools. I'll be demonstrating T-SQL-T. We have a tool called SQL Test that uses that framework. And I'll be showing you that you can use continuous integration build scripts. We have a plugin for TeamCity as well. And there is a white paper that I will place near the door. Or you can collect this at the area where you had lunch at any of the booths, or access it from redgate.com/CI. And this white paper describes in detail why you might want to do continuous integration, pretty much the content of this talk, as well as it's got some examples of how to use the command line to carry out some of these tasks. So what is continuous integration? So this is a definition from Jez Humble. He's a co-author of the book Continuous Delivery, which I would recommend. He describes continuous integration as a practice designed to ensure that your software is always working, and that you get comprehensive feedback in a few minutes as to whether any given change to your system has broken it. So it's all about getting feedback early. If you're running a project and the only point at which you get the feedback is when you deliver bugs to customers, that's too late, because it's very expensive to resolve that, because they have to contact your support team, who try to troubleshoot it. It goes back to your development team. Development team have to troubleshoot the issue. This may be a long time after the code got written, so the developers may not even be working on it. They might not even be in the same job. It might be months after. So that's very expensive to fix. What you really want to do is fix it as soon as possible. So you might fix it when your QA team look at the issue, but that's almost too late as well, because that could be weeks or months after the code was developed. So what you really want is for the developers to notice it as soon as they've made the change, because they still have in their minds what the change was, and they can fix it without having to context switch from another task. So that's all well and good, but what does database continuous integration mean? How does that differ? So I would like to define database continuous integration as a practice designed to ensure that your database is always working and that you get comprehensive feedback in a few minutes as to whether any given change to your system has broken it. So the point I'm trying to make here is that your database code is code. There's no reason to treat that any differently to your application code. And if you do, then you have to ask yourself why. If there are benefits to continuous integration that you apply to your application code, then surely the same must apply to your database code. So this is the continuous integration lifecycle. And just to demonstrate exactly what that is, it starts with a team of developers. They'll make changes to a database, or they might have a database each. These changes get committed to source control. And generally, continuous integration is set up so that triggers the build process. You can set it up to do it once a day if you don't want it to happen all the time, if you've got a very expensive build operation. But generally, on every check-in, you will do a build. And I'll go into more detail later as to what that build does. And then you might run some tests. So if you're running application sort of .NET code, you might use NUnit, for example, run some unit tests on that. And you get feedback to the development team. So this feedback could be everything's fine, but the more valuable feedback is something's gone wrong, something's broken. And that feedback goes straight to the development team, and they should be tasked to fix the problem as soon as possible. So at Redgate, everyone in the project team gets emailed as soon as the build breaks. So it's a bit of name and shame, but it's an important thing to do so that everyone realizes how crucial it is to have a working build at all times. Because if you don't have a working build, then you can't pass that to the testers, you can't validate what you've done, and people get held up. So developers can't take the latest changes onto their local machine because it won't work, it's broken. So you revert back to the previously known good state, and the developer who caused the problem fixes it as soon as possible. I've just included this slide in so you can see how this might feed into a deployment automation process. So continuous integration is something that happens in development, and when you need to deploy changes to your production database, you would go through a separate process. You wouldn't generally want to check in a change into development and have that trickle right through to production unless you're very, very confident. So what we've got here is we've got an artifact of the continuous integration process. So that artifact, we call a deployment package. So it's a database package that our deployment manager tool can consume. And this package contains all the information required to deploy that database. So that can get passed on to your testing environment, for example, staging environment, and production environment. And ultimately, the end user gets it right at the end. So there's a session later on at 4 o'clock. I think it's in this room on deployment. No, it's not. It's in the grey room on deployment manager. So I'd recommend going to that if this is a topic that you find interesting. So again, this shows you the cycle, and I'll just run through a demo that will show you a change made in source control that will trigger a continuous integration build, and I'll go into more detail about what happens here, because that's the meat of what the session is about, and you've got a concept of the deployment artifacts that I described earlier. I'd like to encourage you to put your hand up occasionally and ask questions, because I'm aware that this is introducing some new concepts, and it won't be completely clear, and I've taken a lot for granted, so please just feel free to stick your hand up. So let's see how this works. So who here uses SQL source control? And who here doesn't? Okay, so that's most of you. So I'll go through the concepts behind SQL source control. So you'll have seen already that there's a database in my Object Explorer that's green. And green means that it's been linked to a source control repository. So I've found somewhere in a source control system, created a folder there, and I've linked my database to that folder. And in the folder is a representation of my database. It's a file-based representation, and that's pretty much equivalent to what the database is. So I'll quickly show you what that looks like in source control. Who here doesn't have a source control system in their organization at all? So you all have one, excellent. Who uses TFS? Subversion? Vault? And DBCS, just sort of like Git or Mercurial. Just two. So DBCS, distributed source control systems, seem to be gaining traction at the moment. So I'd predict that if I ask the same question this time next year, about 25% of you would be putting your hands up. It's something that's really taking off. So as you can see, this is Tortoise, which is a way of browsing your Subversion repository. So we have a folder called scripts folder that contains subfolders, one for each object type. And within these subfolders, you'll get one file for each object. So I'm just going to open up one at random. So if I open this one with Notepad, you'll see that it's just, can you see that in the back? I can probably do clever stuff like this. So you can see that it's just a creation table for that object. So we're storing in source control the script that would build the object. This is not a script that you would ever run, because obviously this object already exists, so it's not going to work. It's there just so that we can store a history over time and see what changes happen to that object. So,
question.
Yep.
I noticed immediately after the creation part, you have an alter table. So are you keeping like a history of changes to that table in that file?
No, so the table is not just the table. So we put extended properties, permissions, constraints, indexes, and all of those things belong to the table. So they're source controlled together, which means you can't see on its own how an index evolves over time. You have to look at the table that the index is on. So the history is not held within the object itself, within the SQL. It's held within the version control system. So if I do show log here, for example, this is going to show me the history of the entire database, anything in it. So this is where everything's held. And we'll go into that in more detail later.
Well, maybe later is the time for this, because I don't want to go on too much of a tangent. But as a user of it, I've wondered why things like triggers and indexes are tied to tables. Is there some sort of reason for that they're not source controlled separately?
I would suggest that triggers should be. So I know SQL Compare treats triggers, DML triggers, as being part of the table. And that was a controversial decision, and it was probably the wrong call that we made. It's interesting that Microsoft used to treat DML triggers as as a different object, and they've just moved them as part of the table. So we're not quite sure whether they should be source controlled with the object or not. So it's a matter of debate, because a DML trigger is tied to a table. So you could argue that it is part of the same unit, but it's I don't know. It's a good question. Okay, so this database here is linked to that repository in source control. So anything I do to make a change here will make a change to the file in source control once that's been committed. So I'm going to show you Team City. So this is the Team City dashboard. There are a number of alternatives to Team City. There's Jenkins, there's Cruise Control, there's Bamboo, and TFS Team Build. And they all do the same thing. They all monitor repositories in source control and do things when they see changes in them. And it doesn't matter which tool you use. It should just work, because they don't do anything that's tied to any of the Redgate tools. So here you can see I've got a widget shop project, and there are a few build configurations underneath. And in fact, it looks more complicated than it should be, because what these are duplicates. So this Team City plugin is a duplicate of this MS build sample script, and is a duplicate of the Nant sample script. And this is almost a duplicate, which does it in a more granular fashion using our command line tools. And I've just demonstrated them in here to show you that we do support MS Build and Nant, which are technologies that are supported in all continuous integration tools. So within a build, you can get an idea of how things work. So all build configurations have a version control setting. And this is purely where it's looking in source control for changes. So if I click on here, I will see my repository URL down here, which is the place in source control that it's checking for changes, which is pretty much this subfolder here. So anytime it sees a change to that subfolder, it will trigger something. And in fact, there are different ways of triggering changes. And that's just defined here. This trigger triggers one build for each version control check-in. So this is configured so that if I make any change and commit that to source control, stuff will happen. And the stuff is represented here in the build steps. So these are the things that will be kicked off. And you can have multiple build steps, or you could have just one. Here we have one, which is the Redgate database continuous integration build step that we've written that is exactly the same as the Nant and the MS build scripts I mentioned earlier. And I'll cover that in more detail later. So I'm going to make a change in source control. So the change I'm going to make is to a stored procedure, which is add contact. So I'm going to modify that. And eventually that will open up into a query window. And it's just a normal stored procedure. And I'm going to make a change here. I'm going to change the hello London into hello Seattle. And I'm going to change the parameter data type from a varchar 30 to 20. And if I execute that, I'll press F5, and it's made a change to the database. And if you're observant, you'll see on the left-hand side, we have a little blob here. And that blue indicator tells us that we've made a change to the linked database that has yet to be committed to source control. So this is a change as a developer I've made that I want to test first on my system and before sharing it with the rest of the team. And what I should be doing is thoroughly testing it and only sharing it when I need to. But as a developer, I would be encouraged to commit those changes as frequently as possible, because otherwise, if they build up, chances are if I do check in loads of changes at the same time, someone else gets them, there'll be some sort of conflicts with a bunch of changes they've made. So you want to avoid that by committing as soon as possible.
So the green database icon means this is a SQL source plug-in that is a working copy. It's not actually a database. And when you ran the change, it actually saved the file. It didn't put it in a database?
It is a real database. So the green database is exactly like a yellow database in your Object Explorer. The green just means that that database has an association with a repository in source control. So if I make a change to an object there, I'm just changing a database. And the blue indicator means that it knows that there's a mapping between those objects and the files. But it hasn't done anything at this stage. So nothing has happened to source control. The database change is just a normal database change.
So there's a real database in the server, and there's a working copy somewhere that's mapping.
That's right. So there's a working copy, which is we don't show you, really, because the working copy from your point of view is the development database. And so what I'm going to do now is I'm going to commit this change to source control. So this screen here shows me all the changes that are different between my development environment and source control. The changes I've made since the last time I pulled from my source control system.
When you run that, will it show changes that other developers have committed to the database?
If I'm sharing a database with other developers,
You said it was comparing your local database with what's in source control. If somebody else has already committed a change to source control, and you run that, will it show you the other changes that have been made to source control?
oh, I see. So the question is, will it show me the changes that have been made to source control that I haven't yet pulled onto my system? Yeah, that's what the Get Latest tab is for. So the Get Latest tab will list all the changes that have been made to source control by other developers that I have yet to take into my development database. So we can see there are none here at the moment. So, yep.
Doesn't it also highlight if you have a conflict between the change you're making and one that somebody else is making?
Indeed. So there's obviously a possibility that I change an object and you change an object at the same time. And so if you commit that first, and then I try to commit over that, to prevent me from accidentally committing over some valuable changes that you've made, it will present that as a conflict in the UI, and it will let me resolve that conflict by choosing mine or choosing yours, or what I might do is take your changes and merge them into mine and then recommit those. So because I made the change here, I'll quickly take a look at see what this change is, and let's find it. Here we go. So this is the change I made, so I can review this before committing. So I've changed varchar 30 to 20. So changed email param from 30 to 20. Commit. So what this has done is this has kicked off a process in continuous integration, hopefully. So you've just seen there, it's just kicked off my build, because this is looking in, it's triggered on check-in, and it's looking at that repository, seen the change, so it's kicked off the continuous integration build. So let's go back to the slides while that happens. Oops. So we've seen it started a build, but we haven't really gone into what a build is. So building an application is generally compiling the code, and then that code can be deployed just by replacing the old code with the new code. That's quite simple. But from a database point of view, it's more complex. If you're just deploying a new database, it's pretty much the same thing. You have a creation script, and that builds a new database, which you might do because you might have new customers or new users using your database. But if you've got existing deployments out there, you have existing state to consider. There's data in databases, and you have to get that data into the latest version without losing it. So you might be transforming the data. You might be dropping the data. You need to make sure you preserve the data as you want. So it's an experience that you can't take lightly, not like compiling an application code. So one thing that, whoops, don't want to do that. One thing that you would want to do is test your upgrade scripts. And you can do so continuously because that's what continuous integration is all about. It's not just about running tests on your code. It's about making sure that those changes that you've made to source control can be deployed safely. And if you test your upgrade process every time you make a check-in, when you get to the end of a project and you need to do your deployment, you've done most of the work. You've validated it at every step along the way. So you have a high degree of confidence that you'll be able to deploy that script and it will just work. So as well as testing the upgrade scripts and the creation scripts, you may want to run some additional tests, because making sure that the objects arrive in the state that you intend them to arrive in is fine, but the functionality, the business logic, needs to be tested as well. And you might do this using NUnit in the application layer, and that might talk back to the database layer, and you might test it indirectly that way. But you could also use a SQL unit testing tool. So there's a framework called T-SQL-T, and that's their logo. Sebastian and Dennis have a session later on today, and they cover T-SQL-T in far more detail than I'll cover it here. We have a tool called T-SQL Test that provides Management Studio integration for T-SQL-T. And that's a tool that, the reason why we picked T-SQL-T is because we looked at the frameworks out there, and it was by far the best one. So I definitely recommend you take a look. T-SQL-T itself is open source, so it's free to use. Obviously, if you want to use the Management Studio integration, you need a SQL Test license or the developer bundle. The way T-SQL-T is implemented is that it adds objects to your database. And that's obviously undesirable if you accidentally deploy these to your production server. So you don't want to do that. So what we have is a feature in SQL Compare that ignores T-SQL-T objects, which means that when you create a deployment script, they get removed. So that's an important point to make. We have a tool called Data Generator that you might want to use to generate realistic-looking test data, which you can use either to run tests on, could be T-SQL-T tests or load tests, stress tests, that sort of thing. T-SQL-T, another benefit of T-SQL-T is that it has integration with your CI process. So T-SQL-T can generate a results file that can be consumed by continuous integration tools. So you get to view them within your tool in a quite nice way, integrated into the console. So while I've been talking, hopefully, what we see here is a failed build. And this isn't because my demo's hopeless. It's because I intentionally made a change that I knew would be breaking. So this is telling me that there's one test that's failed and 4 that passed. So if we drill down into this, we can see that test email in add contacts test has failed. I can further drill down into that, and you can see that there's an expected value of SQL in the city. That's actually interestingly wrong. Is it wrapped somewhere? Oh yeah, redgate.com. Yeah, bonus point for you. So why it's wrapped there is interesting, because you would have thought the gate would appear there. Never mind. Team City. It's not a Redgate product. So it's expecting at redgate.com, but it's finding at red hyphen and without the gate.com, and that will be because I changed the parameter from 30 to 20 and caused truncation to occur. So a good thing about the tests here is this is the test integration. So you can see that it's all nicely integrated into the Team City tool. I can click on test history, and Team City will have recorded all the previous occurrences of the test. So you can see some of them have failed, some of them have passed here, and I can drill down and find out why. And so that's quite a nice integration to have, and that's just provided by the T-SQL-T framework. So what I would do at this point is, because that test has failed, I would be named and shamed as part of the Team Cities alerts. Will probably tell some manager or email the whole team, and it's my job to fix the problem because I caused it. So what I should have done is I should have run SQL test before committing the change. So here I've got SQL test, and it's just a little UI that shows me all the tests in the system. And if I find the database I was using, which is probably this one here, and I click Run Tests, it will run through the tests in the little UI and give them little check marks. And as you can see, one has failed. So, and down here, you can see the messages. It's giving me exactly the same information as before. It's telling me that I've got an expected value of SQL in the city at redgate.com, and it only found at red hyphen. So what I can do now is I'll show you what the test looks like. If I double click on the test here, it will open up in a query window. And as you can see, the test is just SQL. So if you're familiar with writing SQL, and I guess all you guys are, you should be able to write tests fairly easily. So you don't need to know how to write C#, for example, and do any unit tests. If you can express it in SQL, you can write a test. And so the test comes, a T-SQL-T test is in 3 parts. It uses a sort of test-driven development paradigm. Assemble the test, act, so run the bit of functionality, and then assert, so say whether it's passed or failed, depending on the conditions. So here I've done the assemble, which is to create a contacts table, and this fake table function will make sure that the table is built without any constraints and data. So it really isolates it from anything that could affect the outcome of the test. Here I've specified some data and executed the procedure that I'm testing. And the last bit is specifying the expected results and comparing the expected against actual and running the assert. So, so let's fix the store procedure. So let me find the procedure. I can just jump to that using F12. So here we go. So I'm going to change this back to 30. And I'm going to press F5 again, and I'm going to apply the change. And of course, I could commit it in source control now, but what I should have done is I should have gone and run my test first. So let's make sure that this test now passes. Yes, it does. So I've tested it on my machine. So I've done all I can as a developer to make sure that it doesn't screw anyone up. So at this point, I can then go back to source control and commit the change.
What built that test? And I ask that because, let's say, it's okay to have 20 characters because all the data in there will fit in 20. You made a business decision to go down to 20. So who built that test originally? T-SQL-T or you as a DBA or what?
So the question is, who built the test? So I guess it depends on your organization. So the best practice is for developers to write the tests. And if you follow test-driven development, developers should be writing the tests before they write the code. And if you go to the test-driven development session later on, they cover that in a lot of detail, more so than I can explain. So, but you could equally have testers that write tests that they check into source control, and these tests would be passed to all the developers as well, because tests are just stored procedures that get placed in source control alongside your database. So a get latest would put it onto the database, and any developer would be running any other developer's tests. So it's a great way to share tests.
So just the act of pulling a new test procedure from source control adds it to the list of tests that automatically run?
That's right, yes. You don't have to run them, of course, but they get added to the list. They're in the list, yes. So it's trying hard to encourage you to run all the tests. So you could have different, so these folders here are called test classes or test schemas, and you could have a different one for each developer, for example, or a different piece of functionality, and you could run them all together. Generally, these tests shouldn't take too long to run, so I'd recommend you run them all if you're using this tool.
So can you arrange the tests to live in one particular, say, unit test database that could then run on a database that you point it to?
You could, in theory, set up continuous integration, as I've done here, and only run it on there. And I guess you could add the framework just to that database. Are you hoping not to have to put the framework on your development instances?
I might need to run a series of tests on, say, hundreds of databases that are very similar or identical in some respects. So it kind of solves the many-to-one relationship between lots of databases and the tests I want to run on each of them.
You could automate adding the framework and the tests to databases. That you can do, yes.
So what if you make changes, one-time change, like agent column to the table? You cannot rerun it or like remove it.
I'm not.
If you add column.
If you add a column.
Add second time. You cannot rerun continuously, right? Agent column, the same thing.
So if the test adds a column, for example.
No, like your script that adds column, and you want to run it over and over.
Are we talking about T/T or?
I'm talking about deployment in general.
Deployment in general. So if you add a column in deployment, that will change the table and add a column there, and that gets saved in source control. But that add column doesn't get saved in source control.
So what if it's continuous deployment? You're running all the scripts all the time?
No, continuous. The way the continuous integration works is that it uses the SQL Compare engine. So it compares what's in source control with, if you're doing an upgrade test, with your production version, and compares the two and generates a script based on that. So if the column has already been added, then that add column will not appear in that script the next time it's run. Do we have another question? I think we had one, maybe not. Okay. So did I commit that change? Probably not. No, I didn't. So I'm going to fixed procedure. That'll do. So I'm going to commit that, and that will kick off the continuous integration process again, and hopefully it will pass it this time if I've done everything correctly. So, right, so let's go back to this slides.
So I'm sorry.
No problem at all.
The data in the database that you're using, where is that coming from? Is that data that you've generated as a developer? Is that data that somebody else is giving to you? Are you pulling data from production?
So the data, where is the data in the development database coming from?
Well, the data in the build database.
In the build database.
That you're testing against when you do the continuous integration.
Okay, so the way I've set it up here is that it creates a blank database in the continuous integration system. So it creates a blank database, meaning with no data. It might have lookup data, so static data, reference data. That gets put in there because that gets source controlled as well.
Right.
And then it will just upgrade that one without any data in it because I've not enabled the data generator option. So you can either generate data with data generator. Alternatively, you don't have to start with a blank database. You can restore a production database if you want into your continuous integration environment and run all your tests on that. And that's a perfectly legitimate test. But I'll come on to that later. Okay. But it's just a bit more expensive, and there are sort of added complications doing that. So what does the CI build do? So what we're doing is we're generating creation and upgrade scripts. And the scripts include schema and static data. So your lookup tables go in source control as well. We'll test the upgrade. The upgrade is tested by applying the upgrade script and validating that the outcome is equivalent to what's in source control. So that's how we do that. We can optionally generate data, run T/SQL unit tests, and we can also generate database documentation. And lastly, we can also create a database package. And the reason why we might want to do that is that that's the format that Deployment Manager uses and it consumes. So let's... Yes?
Is that database package using the SQL packager tool, or what?
No, the database package is created using a new command line that we've now exposed with Deployment Manager. I'm not entirely sure it's available to use right now. Even though we released that tool last week, we released the tool without the database functionality in it. So what I'm showing you here is very, very early stuff. But if you join our early access program, you'll get a build with this functionality in the coming weeks. So, right, where's Team City? So I'm just going to show you exactly what the build is doing. So I've described it in a little bit of detail. If we look at it here, I've set it up just by adding this build step. And this build step I just call database CI. That's just the name. I have to tell it where in my checkout folder to look for the database. So if you remember, the checkout folder was the database here. So I know that my database scripts are in the scripts folder subdirectory. So I've specified that here. This is the server which I'm going to be doing the continuous integration testing on. And this is the database name I've given it. I've chosen not to populate the database with data because it's slightly more time-consuming for a demo. I've said yes to the T/SQL tests and yes to documentation. And I've also added some Deployment Manager configuration here that it needs to create the deployment package. So if you go back to the console here, you'll have seen that 2 minutes ago, this ran again because I committed the fix, and this time it's passed. So we're OK. So this, because it's passed, it will have created the database package, and that's what this is here. So it's an artifact, which is just a file that is a result of the build that is worth keeping. And that package format is effectively a zip file. And it contains the state of the database. And this database state is to validate that once we've done the upgrade, that everything's happened correctly. And we've got the upgrade scripts in here. Oops, didn't mean to do that. So the upgrade scripts belong in here. And we have the state here. And the state here is so that we can check before we apply the upgrade script that the target database is the one that the script was designed to be run on. And if it isn't, then we could fail the deployment if we wanted to. So we do a validation before the deployment and after the deployment. We also have the creation script here and the documentation. I'll quickly show you what the documentation looks like. And if you've used SQL Doc before, you'll recognize this. It's just an HTML view of your database, and I can browse the objects like this and This documentation is documentation you could use within a development environment or give to some customers, etc. So, and of course, the scripts inside the package are just normal scripts generated using SQL Compare. So if I just open the creation script for you, it will probably take a while because we have a virus checking software on here. Okay, fairly sure I clicked on it. Let's try again. Okay, let's wait a bit for that.
David, while you're waiting on that, so how does it take into account the sequence of maybe having to add lookup data? So a common task is you have a table, you want to add now you have, let's say you want to add an attribute to it that is now going to look at a foreign key reference to a lookup table. So let's assume that, which is non-nullable, and I want to have a default value to it. So in essence, a couple things have to happen, right? You have to install a column, you then have to, associate it with the foreign key, you have to, which is normally nullable, right? Then you have to give it some default data, and then you have to have the default to it, and then you have to make it non-nullable. So there's a whole sequence of steps, and I know like when I've had to do deployments in the past, I've actually had to go and manually tweak the files or do some of the types of build.
Yep.
How does this take into account that? Because now it's not just a schema, you actually have to get the data across in a very specific sequence too.
Yeah, that's a very good question. So the question is, what if you have to do something quite complex where data is manipulated as part of the schema change as well? So that takes us, quickly just show you the SQL script. This is just a normal script that that SQL Compare would generate with all this is the creation script, so they're all creates, and this builds your database. So the upgrade script is exactly like that. So, it's quite a good segue to this slide just covers where to find this stuff. So this is redgate.com/SCI. So let's just move on. So
it'll automatically take that, understand that that's a dependency, that it's also got to get that lookup data as well, and plug that in the appropriate space.
yes, so there are situations where SQL Compare would not be able to solve the problem as you might expect if you want to specify a default column. Well, we haven't specified default column value for a column that you've added, for example, a not null column you've added. So that's what I'm just about to cover now, and hopefully this will answer your question. So what if the upgrade script fails? So I don't know if anyone here has tried to rename a table. Has anyone ever tried to rename a table and then tried to use SQL Compare to deploy that change? Does anyone know what will happen? It drops and creates, exactly. So that's obviously not ideal. And if we're using SQL Compare to generate the deployment script as part of an automated process, that's going to fail because it will drop and create, whereas what you really want to do is a rename. And that's a very similar situation to the one you described where SQL Compare wouldn't quite get the script that you want. You want to do some more stuff within that script, and there's no way of telling it what you want to do. And there are a number of cases like this. So I'm just going to make that change just to demonstrate exactly what will happen. Let's get rid of SQL test. Let's find a table. And let's just make sure this is the latest version. Okay. I'm going to change this table from widget descriptions 9 to widget descriptions 10. And if I go to the commit tab, what I can see here is that I'm being told these changes may result in data loss. So SQL Compare knows that it can get it wrong. It doesn't know for certain because you might have actually dropped a table and added a new one with a very similar name. So it doesn't know. It could be more intelligent, admittedly. It could look at the SIDs, for example, or look at the data types and and infer a rename based on that. But it doesn't at the moment. So it's warning you. It says add a migration script to preserve data. We're not going to do that. So we're going to commit thinking it's a rename. So I'm just going to blindly commit. So there are a number of cases where schema comparison tools will struggle. So adding a not null column without a default value. So in this case, this cannot be inferred by a tool because the default value that you want in your column could be absolutely anything. Only you know that information. So there's no chance that SQL Compare can get that right. You have to give it some information, and there's no mechanism to do that within the tool. Renaming a table or column, we've covered that already. And the opposite of, well, splitting a table or column, because when you split a table, you have to tell it which columns go where. If you split a column, you have to say exactly how the columns split. That logic cannot be inferred. That's the opposite of splitting, and effectively any data migration. Any change that involves data being manipulated in any way is something that SQL Compare cannot infer. So we've got this feature called migration scripts. So these are scripts that a developer would define, commit them to source control, and after they're in source control, SQL Compare will know to use these scripts instead of its default behavior. So this is a screenshot of SQL Compare's deployment wizard. So let's say you're going from version 0 to 37. What this is telling us is that from 0 to 36, SQL Compare is doing its thing and generating its scripts based on its difference engine. But 36, 37, because there's a migration script defined here, it's going to pull in the migration script that you've defined and append that onto the scripts. And you can have as many migration scripts as you like, and they'll be pulled in at the right spot because they're tied in to source control revisions. So that's effectively how to solve the issue if you need to do something more complex than SQL Compare can cope with. Question?
Would you use the same technique if there were differences in file groups between environments?
Differences in file groups. So that comes before a transaction, doesn't it? Are you saying in defining file groups?
I mean, like in production, we have more file groups than we have in development.
Okay.
And I'd want a chance to put a table in one of the other file groups before it was deployed to production.
Okay. Probably best if we discuss this later. That's an interesting case that I haven't heard yet. So if you speak to me after the session, that'd be cool. Question?
Does it go back to all the stored procedures, like for a column name change, and make sure that it's going to not crash somewhere?
So the question is, if you make a column name change, does it look at all the stored procedures and make those modifications as well?
Or at least warn you?
Yes and no. The answer is we do have a feature in SQL Prompt that lets you do a smart rename. So if you change a column name, it will change all the references to that column name. And what you would do is you would hopefully use that to make the change. Of course, what you would see in your commit tab is lots of different object changes, and one for each reference of that column, and those would be committed to source control. But if you accidentally don't use the smart rename and you just make a change and you effectively invalidate some objects that are in there, hopefully your continuous integration will pick that up, because when it tries to test the creation script, that will fail because you'll be referencing columns that don't exist. And that's something that SQL Server won't let you do when it builds up a database. So hopefully your creation script test will pick that up.
It will let you alter a table. SQL Server will let you alter a table, change the column, even though there's a stored procedure system.
Yes, and deferred name resolution, I think that's the feature that allows that. Yes, it's a bit arbitrary. I mean, you can create a stored procedure that references a table that doesn't exist, but you can't create a stored procedure that references a column that doesn't exist on a table that does exist. I mean, it's a bit strange, and it's just SQL Server. I don't know how that happened.
Is it SQL Compare or SQL Source Control that's behind the scenes building the creation or update script?
It's SQL Compare. So SQL Source Control just uses SQL Compare's engine to do its get latest and commit logic. So it's just a front end on SQL Compare. Most of our tools, in fact, are just a front end on SQL Compare, including SQL Doc, Dependency Tracker.
Right. So you're basically looking at the target database, looking at what's checked in and doing a compare.
Exactly. And putting in any migration scripts that are appropriate as well.
These migration scripts, do they totally replace the generated upgrade?
They replace the generated upgrade for that specific change.
For that one
Yeah.
step or whatever?
Exactly. So I'll show you how to add a migration script. Let's just quickly cover this slide first. So, of course, migration scripts are essential for continuous integration because that's an automated process, and there's no opportunity to do your manual changes that you might already be doing with your scripts. There's a feature that you can add to catch data loss if you do CI. So what you might want to do is set up your testing so that any time data loss occurs, so it could be dropping a table, dropping a column, truncating a data type, CI will fail. And just in case it's something that you didn't intend to do. And then you could go in and create a migration script to fix it or to validate that change is correct. So let's look at this migration script functionality. First, let's that's bizarre. Oh, okay. Right. So the TeamCity plugin doesn't yet support migration scripts, and it's just occurred to me. So let's just disable this build trigger here. And this is the one that works with migration scripts, which is one that, so we'll soon be merging this functionality with this functionality, but it's just a demo machine. Apologies. So we're just running this build here. So this build here, incidentally, if we look more closely at it, runs an Ant script. And an Ant script is expressed in XML. It's called upgrade script.build. And if we take a look at this, I might scare you a little here, but let's do it anyway. I think. Here we are. Okay, here we go. So this is an Ant script. So this is an alternative to if you're not using TeamCity and the plugin, or you want to do something more complex, you might build a script like this. And Nant and MS Build are standard formats that are used in most continuous integration tools. So if you have someone that's set that up in your organization already, this will be very familiar to them. But the point I'm trying to make here is that you've got references to our command lines here, and then it's just like a glamorized batch file, so to speak. So let's go back. So I've tried to run this build, and as you can see, it's failed. And whoops, I don't want to do that. Let's investigate why it's failed. So you can check out the log. So this is the output of the command line. It's not particularly nice to read at the moment. But if we scroll down, what we can see here is it says, warning, the table widget descriptions is being dropped. Any data in the table will be lost. You can use a migration script. So this demonstrates how to use continuous integration as a way of catching unexpected data loss, because this is data loss that I didn't want to happen. So I haven't yet created a migration script, so let's just do that now. So let's go back into SQL Source Control, close this dialog here, and we have a migrations tab over here. So add migration script. This dialog will show me all the changes I've made recently. This is like a history dialog showing all the changes. And I can select a change, or I can select a range of changes that represent the changes I want to write the custom script for. So the one that I typed, I think this is a rename for. You can see that it's got a new file called widget descriptions 10, and it's dropping a file called widget descriptions 9. So I know that this is the one I need to replace. So clicking on create and edit script now will load up a query window, which gives me the default SQL Compare script. And this is not because it thinks it's getting it right. It's just giving me a starting point, because it might be a small tweak I need to make. And as you can see here, you've got a drop table and a create table. And that's exactly not what you want, because the drop table will lose all your data. So what I want to do instead is I want to take widget descriptions 9 and SP rename it. So let's type the SQL that I should have used. So I want that, but I don't want anything else. So I'm just going to select the rest of it and delete. So now I have my change. This is the script that I intended to use in the first place, and it's probably the one I used to make the change. And I'm just committing that in source control so that SQL Compare knows that I want to make this change instead of the drop and create. So I click proceed to commit, yes, save, and it'll take me to the commit tab. And I can review the script here as I could before, and adding migration script to do SP rename instead of drop create. And I commit that to source control, and this will, well, if we go back in here and run the build, because I haven't set a trigger on this one, it will run through, and this time it will pass because it will use that migration script.
So I'm devious. What would happen if we renamed table 9 to table 10, but in my migration script I said rename table 9 to table 8 or something else that doesn't match what the actual change was?
That's a very good question. What if the migration script doesn't actually make the change that it's supposed to? What will happen there is that in the continuous integration upgrade test, it will fail on the post-deployment validation. So, but after the upgrade scripts, what we do is we look at the schema of the database that's been upgraded and compare that against the checkout from source control. And there'll be a mismatch there, and it will fail the build, and then you'll know that something's wrong, and you'll go back and fix it. Question?
So if a change was made in the database that requires a migration script, and then there were several check-ins, and then we realized, oops, this particular part we needed to have an upgrade script, you'd go back and select a range of check-ins, or? So
the question is that you have a number of changes as part of the check-in, and only one piece needs to be changed.
Multiple check-ins.
Multiple check-ins, and so the drop and create could have been separate check-ins, in which case I could have selected 2 revisions in source control and created migration scripts over those 2 revisions. It just so happened that I committed them at the same time. But I could have committed the drop in one go and the create another time.
Okay, so when it's creating the migration scripts in the future, will it take that change as replacing everything for those check-ins? Because what if there were other changes that were just fine?
Yes. Will the migration script replace all of the things? Yes. So the migration script has to make exactly the same change as would have been made by all the changes in the revision. So if there were some alter stored procedures alongside the drop and create table, you have to keep those in the migration script. Otherwise, you'll fail on the post-deployment validation.
So what I've done as a technique to handle that, and tell me if this is a good idea or not, is to sort of revert back to the previous and create a check-in that only handles the change that you want to create a migration script for.
Yep, that's a really good idea. So reverting the change, if you want to separate out just the change that needs the migration script, you could revert back and then recommit them as 2 separate check-ins. That's a really good idea. Have we run out of time? Oh my God. Sorry, one last question then.
Yeah, I'm just wanted to ask what is the detail of that testing, the CI testing for migration script? Is that going to build a previous version and run a migration script?
Yes, exactly. So that's what it does, yeah.
How do you find out which one to run?
So this one's hard-coded, but in future, we plan to ask Deployment Manager for the information. All right, I think we better call it a day. If you've got any questions about this, I'll be downstairs near the big screens. Thank you very much.